Hey guys, okay, so one thing I want to talk about today is we started the year with one-dimensional graphing, just on a number line on an x-axis here, and then recently we've transitioned into two-dimensional graphing with an x and a y-axis, and I want to make some connections here. So let's say we had this. So we have absolute value of x minus 2 equals 0. Okay? And so when we did this earlier in the year, we isolate the absolute value of x, and once we have isolated that absolute value of x, then we'll split it, and we'll say that x could be 2, or negative x equals 2, therefore x equals negative 2. And we could come over here to this number line, and we could graph that. We could say this dot and this dot, right? Good so far, outstanding. Well, how does that relate to transitioning into the two-dimensional world? Here we only have one letter, just an x. We don't have a y anywhere. So we talked about, okay, if you only have one variable, then we can graph that in that one variable's dimension. But let's see how we can make some parallels as well. Wonder if this expression over here on the left-hand side, if we considered that a function of its own. So let's say f of x equals absolute value of x minus 2, and I'll even write that over here. I'll say f of x equals absolute value of x minus 2. And then what about this guy? Let's treat this as his own function. Let's say g of x equals, and down here we can say g of x, this other function, equals 0. And then we can go about graphing that. Let's see if we can graph that bad boy. Go here, go here, go here, go here, we'll make it green. Okay, and so to graph this bad boy, we would say, another way to say that is y equals absolute value of x minus 2. The vertex, that's has a, here I'll rewrite that as O. I want that to be green. Okay, so y equals absolute value of x minus 2, vertex at 0, negative 2. It's facing up and has a slope of 1. So we'll go down to that vertex. Now let me switch over to a line and make sure it's green. Okay, so then we'll go here with it, up 1 to the right 1, and up 1 to left 1, something like that. It's just a tad off. Let's see if I can move that bad boy down. Okay. Okay, so, and that would be our absolute value graph of this function, right? This green function. Well, let's do the same thing, but for the second function. The second function, g of x equals 0. Y equals 0 is a horizontal line right there. Let me move that down. So that's fine. Okay, and voila, we have our two functions graphed. And let's check it out. Where do they intersect? where does this function equal this function? That means what points do they have in common? And they cross just like a system of equations now. This equation, as a system of equations, and they cross right there. And lo and behold, they see how that is crossing at 2 and negative 2, and that point is that point right there, and this point corresponds with that point right there. So it's pretty cool that a one-dimensional situation, we can now start expanding our vision into how that might be considered two equations, and where those two equations or two functions are equivalent will match up with the same if we considered it just the old-fashioned way as one equation. So let's see what happens then if we change that. If we change that to an inequality. Okay, an inequality here where let's see what happens here, and then this one will flip when we divide by -1. Okay, so if we did it the old-fashioned way, we would still isolate that absolute value, then we'd split it, and the additional thing that we would do is, let me go blue with it, is less than. It would be in, I'm sorry, what am I talking about? That's a greater, thank you for, okay, so that's a greater, thank you. It'd be this is an or, a greater, so it's an or, and we would come down to our number line and we'd say it's greater than 2, so we'd shade this way with it, and it's less than -2, and we would shade that way with it, and it would be an or, so that's just wherever there's shading, and so that would be our answer. X could be anything larger than 2, like 3, 4, or 5, anything less than or equal to -2, like -3, -4, and so on and so forth. Okay, well then, let's see how that plays out in this neck of the woods. Let's see, this would be, we're still going to keep this as equals, because we're saying f of x equals absolute value of x minus 2. However, what we're going to look at is this. Now, what does this mean if we're talking about two dimensions, about this function versus this function? Well, doesn't it kind of mean, it means this. It means this function, the y, remember this is y equals, the y values are greater than these guys' y values. Does that make sense? It says if f of x is greater than g of x, it means this y value is y1, let's call it, is greater than these y values, y2s. So greater than means above. Above. Whoops. What's going on there? I'm going to delete that. Okay, so there we go. Where is this v-graph, or this function's curve, above this function's curve, or the line? Well, where is this v above this line? Is right here, right? Right here. Above or equal to. It could be equal to. I guess I should still circle in these dots. And so when we're solving this for x, it means for what values of x, what x's make this true? What x's make this y above the graph of this function's graph, above this function's graph? Well, again, these x values make that happen. See how this portion is circled? These portions of this V graph? What x's correspond with these little portions? Well, these right here. And you see that these two arrows, these darkened blue arrows correspond with these same darkened blue arrows. And we could do the same for, let's take this, okay, absolute value of x minus 2 is less than 0. And we'd isolate absolute value of x less than positive 2. We'd split it. X is less than 2. X is greater than negative 2. And let me see if I can erase. There we go. There we go. And let's see how that plays out. So, okay, x is less than 2. Here's my 2. X is greater than negative 2. Negative 2. And we would see that it's once we've isolated that absolute value, it is an and because it's less than. So that is only where they overlap. Do it the old-fashioned way, like meaning chapter 1 way. Okay, and that would be our answer. Here, let me do that again. It would be right in between these two guys, right? Okay, well, let's check it out. What does that, let me see if I can, how do I get a smaller, okay. Okay, so what does, now let's split it. Let's take this function and this function, and we'll figure out what that means. So this function y equals, this y equals absolute value of x minus 2 is still this green V. And this green will, I'm sorry, this less than will mean below, right? It'll mean below. Where is this function below this function? Right? So where is that? I should have kept green here and red here. I messed up that way to keep it, you know, correct. But let's go. There we go. Well, where is it below? It's below the V graph. The absolute value function is below. It's less than this function, which is a line right here. This is the portion. I'm circling this area. And so what x's correspond with what x's, oops, gosh dang it, what x's correspond with that area? These x's right here. These x's. And since it's less than and not equal to, check that out. It is the same as your one-dimensional graph right here. Isn't that cool? So now we can interpret this two-dimensional graph in terms of, is it do we want the above portion or the below portion, and think what x's correspond with those different regions. In this case, the above region corresponded with the x's going out, and the below region corresponded with the x's in between the two intersection points, and which gives us the same results as if we did it by a one-dimensional method. All right, awesome. Hope some light bulbs came on just now, and I'll see you soon.